Whoops. And I will be very, very explicit and try to draw in all of my relevant hydrogens here to help keep us on track. And I will try to remember all of my lone pairs and all of my charges, so I'm not a bad person. And here we go. That's an example of how we go from the keto tautomer to the enol tautomer. Thoughts or questions at this point? Is water able to pull off the hydrogen? So you mentioned the term addition elimination. Now we've seen addition elimination in acid chlorides. That's where a nucleophile adds to a double bond. We kick up a lone pair of electrons. It comes back and pushes something out. Nucleophile, like an amine, adds to an acid chloride. We kick electrons up onto the oxygen. They kick back down, kick out the chloride. So this reaction mechanistically is an acid-base reaction. And the only thing that's maybe surprising or confusing to you is the fact that we're continuing to push our electrons all the way up. Now, technically, I could go ahead and stop at this point. But of course, if I stop at this point, I recognize in my mind's eye, well, this is a really, really funny resonance structure, a really unimportant bad resonance structure. Of that. And so we just keep pushing. And of course, protons come on and off all different acidic positions in acid-base equilibria. And so the proton, whoops, I forgot my positive charge. So much for being a good person over here. So the protons can come on and off the oxygen, then we head in the reverse pathway. And guess what? Most of the time, your equilibrium partitions back. In other words, when you have an equilibrium like this, so here's our energy, here's our reaction coordinate. When you have a reaction like this, where we're going from reactant, from our acetone plus H3O plus to our protonated acetone, and then to the enol, and technically, if I'm writing this out correctly, this is acetone, protonated acetone plus H2O. What's happening in our mechanism is first we're going uphill to an intermediate, and then we're coming down to our product, to our enol that's higher in energy. So when you're at this point, at the intermediate, you can partition back, you can partition forward. It goes both ways. Most of the time, it actually ends up going back down. And ultimately, of course, it's the difference in energy between our product and our reactant that determines the position of the equilibrium. There was another question. It does indeed take the H from the oxygen. And the mechanistic reverse of this step is taking the